Welcome to the project demonstration of wireless power transmission with solar power. So here we are using the solar panel along with grid power supply to charging of a battery pack. So here using this solar panel for charging of the battery pack as a renewable source. Just we need to connect the solar panel at this slot. So this is the connector to the transformer. So the main application of this project is whenever we are driving a EV vehicle, as it consists of a battery which is a rechargeable battery pack. So in order to charge a battery pack, there are normally the conventional ways to get down from the battery car, and we need to connect the charger. So this is not safe every time. There may be chances of short circuit or heating occurred, and inside the battery pack the life of the battery pack will be decreased. In order to remove all these problems, we come with a solution of wireless power transmission. Means wirelessly we are going to charge a battery pack by transferring the power from one coil to another coil. So this will called a wireless power transmission concept based on the mutual induction concept. Okay, nothing but EMF. So here the EMF will be generated at the primary coil. This is called the primary coil. So the EMF is nothing but converting DC to 125 kilohertz of AC signal. Means when we want to provide or generate the EMF signal near the copper coil, then it will generate the EMF signal when we provide the AC signal to that. Means to provide the EMF signal, we need to provide the AC signal to the copper coil. Based on the frequency and the power, the distance of the EMF will be varies. So as of now we are providing 12 volts 1 amp power to this copper coil. So it can generate around of 5 centimeters around this copper coil, which is called as a transmitter coil. So when we place the receiving coil, this is a secondary coil, it will get induced when we place the EMF of this transmitter coil region. The induced EMF will be converted into the AC voltage, and that AC voltage will be converted into the DC voltage with the help of these circuits. The DC voltage given as input to this LED indication, which is showing the status of wireless power transmission concept. To achieve this concept, we are using this 12 volt 1 amp DC battery pack, which is rechargeable through the solar panel as well as through this transformer. So when we want to charge a battery from the transformer, just connect that to the 12 volts AC input. The light indicated the battery is charging through this transformer, and when we place this solar panel under the full sunlight, we will get the light indication from this also. So if we place the charger with the grid, then it will take 4 to 5 hours either from the grid or from the solar power. So if we place the both at a time, means we are getting the both power sources sufficiently, then it will get fully charged in a duration of 1.5 hours to 2 hours maximum. Before that only the battery will be discharged. So battery will be fully charged. So we should keep the battery under full charge before demonstration of the project. So once the battery is fully charged, just you can on this power supply, as it shows the indication of the transmitter got switched on. So when the vehicle is coming in this transmitter coil region, you can see that. So at this distance only, so it's directly on the coil. So just I'm lifting that around 5 centimeters of distance. So it is getting powered to the receiving coil. Okay, right. So when we are on the transmitter coil, then it will get induced and it will be converted into AC to DC, and that will be given as input to the LED indication. Right. Okay. And coming to these charging circuits, so both are look like same charging circuits. Each charging circuit consists of rectifier to convert the AC to DC when we providing the AC power source. But coming to the solar panel, which will provide as a DC source, that will be converted. No need to convert the AC to DC as we are providing the DC. But here these 4 diodes will acting as a polarity correctors. Means whenever the solar panel is DC, so it has a polarity based. So if we may connect this in reverse direction, then the plus and will be connected to the minus of the battery pack, so that the battery or solar panel may get damaged. In order to protect that from this polarity protection, then we are using these 4 diodes will acting as a polarity corrector, means nothing but polarity protection purpose. And these 2 diodes unidirectional current flow. So whenever the battery is fully charged, so these 2 diodes will block the current flow from the battery to the solar panel in order to protect from reverse current protection. And LED indication just will show the status of power availability from the respective source. Thank you.